Today on How It's Made. Grinding wheels. A rough job, but someone's got to do it. Compost. Production that's supposed to break down. Window blinds. A shady business. And milk. Old MacDonald goes high-tech. A grinding wheel is a tool used to grind down, polish, or cut materials such as metal or glass. Like a sander, it uses abrasive grains to wear away the surface in minute particles. Grinding actually sharpens the wheel by breaking those grains and creating new sharp points. A grinding wheel is made from several chemical and mineral ingredients. The formula varies according to what the wheel will be intended to grind, polish, or cut. For metal work, they use abrasives that are aluminum oxide based. For cutting cement, stone, and other non-metal objects, they use abrasives that are silicon carbide based. Even within those two categories, the formula differs between, say, a wheel designed for hard steel versus one designed for soft steel. Computer-programmed scales automatically weigh the various ingredients, including additives such as iron oxide for wheels that cut or grind iron, and the mineral cryolite, which lubricates the abrasives. Powdered and liquid resins bond all these ingredients together. The powdered resin and additives are the first ingredients to go into the mixer. After about a minute, the abrasives and liquid resin go in. Another 5 minutes of churning, and the mixture is the consistency of damp beach sand. They screen out any globs or chunks so that the mix has a smooth and even texture. A device called a shuttle spreads the mixture into a wheel-shaped mold. The diameter and depth of the mold cavity corresponds to the dimensions of this specific grinding wheel model. At the base of the mold is a reinforcement disc made of fiberglass. Next, a galvanized steel ring goes in the center of each wheel, its 4 small anchors gripping the mixture. This ring is designed to protect the shaft that spins the grinding wheel. A hydraulic press now compacts the material, applying up to 350 kilograms of pressure per square centimeter. That's the weight of about 30 cars. Every single grinding wheel coming off the line is weighed to ensure it meets design specifications. Next, the wheels go into an oven whose temperature rises gradually from 20 to 200 degrees Celsius over a period of 24 hours. This cures the resin, bonding all the ingredients together. When the grinding wheels come out, they're hard as a rock. The last step of the production process is labeling. The automated machinery moves the wheels from station to station using suction. It applies 8 drops of hot glue around the center, then slaps on the first label. The label bears the manufacturer's logo and lists the grinding wheel's dimensions, its intended use, and the maximum spin speed. The equipment then flips each wheel and glues a second label onto the other side. This label lists the safety information. The The diameter of a grinding wheel can range from just 5 centimeters to more than 50 centimeters. It can be just a millimeter thin or up to 12 millimeters thick. The smallest wheels are designed for things like auto body work, while the largest ones can cut through railway tracks and thick metal construction beams. Many gardeners are relying on nature to nurture their gardens. They're choosing compost-based soil mixes over chemically fertilized mixes. Compost is decomposed organic matter. Not only is it environmentally friendly, it's chock full of nutrients and useful microorganisms. Composting is the ecological alternative to burning or burying organic waste. It all starts at this composting factory, with manure from farms, biodegradable solid waste from paper mills, and grass clippings and leaves from municipalities. Some materials arrive in bulk, others in plastic garbage bags. Workers carefully inspect the leaves and grass clippings, removing any non-biodegradable objects that got into the bags. Things like pieces of plastic, rubber, or metal, shards of glass, or even stones. After combining all the waste ingredients, they add bulking materials, such as wood chips and bark. Then they stack the mixture in outdoor piles to decompose. The mix's makeup is by no means random. It's scientifically designed to create an ideal environment for live microorganisms. Billions of bacteria and fungi grow and reproduce, feeding on the nitrogen and carbon that are naturally present in the organic matter. They slowly and gradually transform the waste into compost, which, when ready, will look like rich black earth. All this microbiological activity heats the waste piles to a steaming 65 degrees Celsius, even in the dead of winter. The factory turns the piles monthly to aerate them. This stimulates decay and ensures it occurs evenly throughout the pile. The active breakdown phase takes 6 to 10 months. A curing phase follows, an additional 6 to 8 months, at the end of which the compost stabilizes. Because the outdoor piles are exposed to precipitation, high concentrations of nitrogen, phosphorus, and potassium leach into the runoff water. Drainage ditches collect and carry this water to holding ponds. From there, it goes through a treatment system consisting mainly of aeration and settling ponds. As we see in this demonstration, they aerate the water and add certain chemical compounds. The pollutants bond and settle at the surface to be skimmed off. The treated water has to meet strict government regulations before it's released to the environment. Back to the compost now. Once the curing phase is over, the compost goes through a screening process which removes any lumps or foreign objects, such as pebbles or partially decomposed wood chips. The finished compost comes out silky smooth. Before the compost is sent to market, it undergoes strict quality control testing. The factory's laboratory conducts detailed chemical analyses to ensure the compost is at precisely the right level of maturity and that it contains the correct balance of nutrients and stabilized organic matter. Then, a series of growth chamber tests. To ensure the product performs well, the lab germinates seeds and grows test plants in compost-based mixes. Once the quality control department gives the green light, the compost can be shipped out, either in bulk or packaged in bags. Compost is sold as is or added to soil mixes. It improves the soil's structure and actively retains moisture and fertilizers. Compost is a chemical-free way to nourish plants and stimulate their defense systems. This gives them extra strength to grow fast and stay healthy. Today's window blinds come in many styles. Roller shades, roll-up shades, pleated shades, and horizontal blinds, to name just a few. The advantage of horizontals is that you can leave the blind drawn and simply tilt the slats to let in tons of light, a bit of light, or no light at all. Most manufacturers make their wood horizontal blinds from basswood. It's a hardwood, so it's durable. It's lightweight, so the blind doesn't end up weighing a ton, and it absorbs wood stain evenly. First, they feed the rough wood through a planer. They cut it down to 5.3 centimeters, the width of the slats. Then, following a laser guideline, they trim off any excess and square the piece using a straight line rip saw. Now the piece goes through a machine that's specially designed to cut thin slats of wood. Its sharp steel blades slice right through, creating up to 15 slats, each 4 millimeters thick. Here's the piece of basswood before slicing and after. The slats now pass under an oscillating sander to prep them for staining. After cutting them to the width of the window, workers spray wood stain on both sides of each slat, then a coat of sealer to lock in the color. Once the sealer dries, they sand the slats manually to prepare them for a final protective coat of lacquer. Next, using a die, they punch 2 slots in each slat, 15 centimeters in from each end. These are for the color-coordinated cords that will operate the blind. Now for the assembly. They hang ladder-shaped cords called ladder tapes from the blind's head rail, then slide 1 slat onto each rung. Then they thread the blind cord through the slots in the slats, hooking it up to the control mechanisms hidden in the head rail. A cord dangles down the front for raising and lowering the blind. They also mount a wand or cord for tilting the slats. The excess ladder tape is tucked into a bottom rail. To make aluminum blinds, they start with long strips of preformed steel. These will be the blind's head rail and bottom rail. Workers cut them to the required length, which is the width of the window. They make holes in the head rail for the cord lock, the device that locks the blind to the desired height, and the tilter, the mechanism that angles the slats. Now they install those components. The cord lock snaps right into the hole, no hardware required. That's known as a pressure fit. They pressure fit the tilter as well. Next come the tape rolls, through which they run the ladder tapes. They cut the appropriate length and color of blind cord, then thread it through the cord lock. The tilter turns a rod which turns the tape roll, which tilts the ladder tapes, angling the slats. And speaking of slats, they're cut from rolls of 2.5 centimeter wide aluminum. Workers simply feed a roll into the forming machine, then the rest of the process is automated. First, the machine gives the flat metal a semicircular curve. Then it punches cord holes, and then, as you see on the far left of the screen, cuts it into slats. But that's not all. This same machine also assembles the blind, sliding a slat onto each rung of the ladder tapes. All that's left to do by hand is thread the blind cord and install the bottom rail. From this point on, it's just window dressing. Getting milk out of a cow has sure come a long way since the days of sitting on a stool and pulling teats. Today's cutting-edge dairy farms are fully automated. Sophisticated equipment feeds the cows, cleans up their manure, milks them, and even checks the quality of the milk. Historians aren't sure when humans first began drinking animal milk, but they believe that people in ancient Babylon, Egypt, and India raised dairy cattle as early as 4000 BC. For centuries, the family cow was the main source of milk. But as cities became more populated, keeping your own personal cow became rather impractical. So farmers living outside city limits began to establish dairy businesses. The key to good milk output is a good diet. Every day, a dairy cow chows down up to 45 kilograms of feed, a mix of hay, grass, and grains, supplemented with minerals and proteins such as soy. On a hot day, she can drink the equivalent of a bathtub full of water. Cows produce milk only during the lactation period that follows giving birth. Starting at 15 to 17 months of age, they're inseminated yearly for about 6 years. The newborn calf suckles for a couple of days, then goes to a separate area to be raised. But the mother continues to lactate for another 10 to 12 months, to the tune of about 35 liters per day. This is the milk that's collected for human consumption. The barn floor is automatically cleaned around the clock to prevent the cows from walking in their manure, which would spread disease and infection. Animal welfare is at the core of this state-of-the-art dairy farm. A happy and stress-free cow, after all, produces better milk. So these cows aren't confined to stalls. They walk around freely, inside or outside, eating and drinking as they please. They scratch themselves against this motion-triggered brush. It improves their blood circulation and cleans their hides. Each cow wears an identification tag. It emits a low frequency, a different one for each animal. This enables the computerized milking system to collect data on each cow's milking habits and monitor the quality of her milk. No traditional twice-a-day milking here. The cows decide when they feel like being milked. Just like the pressure in our bladders tells us when it's time to go to the bathroom, when the cows find the pressure in their udders uncomfortable, they just mosey on down to the milking stall. The stall is designed not to force the cow into an uncomfortable or motionless position. It's set up in such a way that she's not separated from the herd. Scientific research shows that separation induces stress. As it prepares to clean her udder with disinfectant and water, the robotic milking system reads the ID tag and records that this is cow number 328 coming in for a milking at 4:41 in the afternoon. Next, a laser pinpoints the exact location and position of the 4 teats. It feeds that information to the computer, which then guides the robot to attach the teat cups one by one. Once the robot detects the presence of milk, extraction begins, each suction cup simulating the suckling action of a nursing calf. A sophisticated machine analyzes the milk. If the quality is not up to par, or if the machine detects signs the cow has an infection, milk with elevated temperature or minute traces of blood, for example, The system automatically rejects the batch and red flags the problem cow. As the udder cleaning brushes get disinfected, the robot tracks the output of each teat separately. That way, no teat is undermilked or overmilked, which can lead to health problems. Once the suction cups come off, the robot disinfects each teat. As Bessie goes on her way feeling mighty relieved, the robot disinfects the teat cups for the next cow. The milk that passes inspection collects in a jar, then gets transferred to a giant refrigerated reservoir. They wash out the jar between cows. To keep the milk fresh, they store it at 3 degrees Celsius, about the temperature of your refrigerator. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.